Okay, so last time I hinted about how you could predict multiple things at the same time. And one of the things I wanted to go deeper into was, let's say you have a classification task, but it's not just a binary output, that it's not just yes or no, is it going to rain tomorrow or is it not going to rain tomorrow? Let's say you have to classify between different types of plants. And so there could be five different types of plants, or like basically more than two. And so how would you go about doing that in like logistic regression, let's say? Let's say you only wanted to use logistic regression and not a neural network. How would you go about doing that? Well, I want to draw a simple example for you. So this is a graph, and this is feature number one, which is whatever the x coordinate is, and feature number two, that whatever the y coordinate is. And then let's say we have a couple of circles here, and we have a couple of triangles here. Now, the point of logistic regression is to divide these two right here. Is it a circle or is it a triangle? If it's not a circle, that means it's a triangle, right? But what we're trying to do is do multi-class classification. So just to be clear, I want to make put one thing aside, which is if you do logistic regression on this, it will use a line, specifically a line, because that's what was there before we did the sigmoid. So remember, sigmoid of like W1, X1. So this is, let's say, X1, and this is, let's say, X2. So W1, X1 plus W2, X2 plus B, whatever B is. Um, this right here is the function of a line, right? And because this is a function of a line, it will use a line to separate these two. It will always be specifically a line, nothing else. It won't be a curve. It'll be specifically a line. Unless you use a neural network, and that in which case you're doing more than just this. Well, okay. So now we've separated these two classes. But let's say I added a third class, which was stars. Okay, there's a star there, and a star there. Okay, and I want to be able to use logistic regression to separate these three classes from each other. So the solution to this problem is basically training three different logistic regression models. So one is it a circle or not? Right? I would use, so number one would be circle or not, right? And then that would basically be like, this would be a value of one, value of one, value of one, value of one, and all of these would have value of zero when it comes to that situation. Um, and the second logistic regression model is similarly, is it a triangle or not? The third one would be, is it a star or not? Right? And by asking ourselves these three questions and training a logistic regression model on each of these three situations, what we end up doing is we end up, for the first one, for number one, we would basically create a line between these two. We would treat this as the same group as this, right? Stars and triangles are both just not circles, right? And so this would be basically line one. And then line two would correspond to grouping this as one group and grouping this whole thing as one group. And we just want to separate the two. So what we might do is draw a line like this. So this would be line two. And number three would basically be trying to separate stars from non-stars. So stars from non-stars. And it would just be like that. And this would be line three. And so all three of these are lines. And what we've done here is, if we want to determine if a certain thing is a star or not, then what we can do is we can run this one, right? And if we want to figure out if it's a circle or not, we can run this one. But what if we want to just find the class in general? We just have an example, and we want to find out what is that example. And so what we can do is like draw, just put our new example up here. Let's say over here. right? And so what this will do is it will see, is it a circle or not, right? Based on line number one. And based on line number one, since it falls on this side, yes, it would be considered as a circle. So let's say the probability of that would be like 0.9. And over here, it would ask, number two would ask, is it a triangle or not? Now, it's on the opposite side of the triangle line, so it would be, no, it's not a triangle. So it's like maybe 0.2 or something like that. And then, is it a star or not, based on line number three? So it's way beyond this line. And by the way, this line represents when this value is, this whole value is equal to 0.5, because that's where we're making our threshold, right? That's where we're deciding whether or not it's a star or not, right? If it is a star, so everything on this side of the line has a value of greater than 0.5 probability of being a star, and everything on this side of the line has like less than 0.5 probability of being a star. And on the line, it's exactly 0.5. And so I just wanted to make it clear. And that's why over here, maybe this x could be approximately 0.1. It's very far from the line, so we'll say 0.1. It's actually further from the line here than this one is to the line, line 2. And that's why I made it 0.2 and 0.1 rather than this being bigger than this. So that's a small technical detail. But basically, now that you have a probability of whether or not it is each of the classes, like I said last time, you could just look at the one with the highest probability, and then you could say that this is the one that it is. So it is considered a circle. So the x is marked as a circle. And that's one thing we could do. But one thing you'll notice is that when we add this up together, it does not equal 1. It actually equals 1.1. So because this equals 1.1, we can't make a really good interpretation of this. One thing maybe we'd like to do is say, oh, it's a 70% chance that it's circle, maybe 20% chance that it is a triangle, and then maybe a 10% chance that it's a star, right? And then that these things add up to 1. And that would give us like a good representation or a good explainability for what our model is outputting. And in order to do that, one thing we could do is, since all of this adds up to 1.1, we could just divide each of these by 1.1. So we could just do this divided by 1.1, divided by 1.1, divided by 1.1. And then that would essentially do this thing, what we call normalization, or it would essentially scale the original outputs in order to make them sum to 1. And so if you think about it, 0.9 over 1.1 plus 0.2 over 1.1 plus 0.1 over 1.1, how do I know that that is going to equal 1? Well, it's because if you add up all of the numerators, you add 0.9 plus 0.2 plus 0.1. Oh, sorry, I made a mistake, by the way. This should be 1.2. 1.2. And yeah, I made that mistake. Okay. And so how do I know that this will sorry, I was coming back to this. So how do I know that this will sum to 1? It's because if I add the stuff in the numerator, that's 1.2, and that's actually what we did in order to get the 1.2, which was what we divided by. So if we get 1.2 divided by 1.2, we get 1, which is now we can interpret this as a probability that 0.9 divided by 1.2 I think is 0.75. So it's a 75% chance of being a circle. And then what is this? Approximately like 0.16, I think. And then this should be like 0.8 something, I think. But basically, like, all of these would end up adding to 1, 0.08. Yeah. So there's like an 8% chance, 16% chance, 75% chance for each of these classes respectively. Yeah, so thank you.